Welcome back to Grade 7 Math, lesson number 12.2, Solve Equations by Inspection. In today's class, we are going to learn how to use one method for solving equations. This method is known as inspection. Solving equations using the inspection method is like balancing both sides of a scale. Just take a look at these two here. Okay, we have 3 plus 2 on the left side, and we've got 4 on the right. And yes, 5 is greater than 4. Here's a problem though. We're imbalanced because one side is greater than the other. Okay, whereas if we look at this diagram here, we've got 3 plus 2 on the left. On the right, we have 5. So the scale is in perfect balance. Now here's what we're going to do through this video and in tomorrow's class. We're going to use the cups and counters from our previous lesson to solve some sample inspection problems. So remember, the cup represents the variable, the unknown amount, and the counters represent the number that we do know. Here are two diagrams which you can copy using your cups and counters. Okay, you can try this at home and we'll try it in class. For each diagram, try determining how many counters should be placed in the cup so that both sides have an equal number of counters. Well, just using inspection here, we can see that we've got one cup, we've got 2 counters. On the other side, we've got 3. So in order to make both sides equal, it means we need one more counter to go into the cup. Okay, and let's look at this one as well. We've got one cup, but we're going to take away 5 of these counters, meaning that there's 2 left. Well, 7 take away 5 equals 2, so that means that there would have to be 7 counters in this cup in order to cancel out the 5 to give us 2. Okay, give these two problems a try at home. Okay, if you have actual cups and counters, you can use them, or you may just have to draw diagrams here. But what I want you to do is determine how many counters would go in each cup. So put the video on pause and try this out at home, and we'll take it up tomorrow. Now, let's try something a little different. Let's take a look at the pictures on the next few screens. And what we're going to do is we're going to figure out the value of the variable, that's the letter, in the pictures. So we've got 3 triangles which are equal to 6. So we can say 3k equals 6. So you have to think, okay, well 3 times what equals 6? Well, 3 times 2 equals 6. So k must equal 2. Okay, here's another one we'll demonstrate on this video. We've got m plus 3 equals 12. So what must m equal in order that we get 12 on both sides of the scale? Well, 9 plus 3 equals 12, so m must equal 9. Okay, put this one on pause and try to figure out what x equals. Okay, here's an interesting one. We've got a on one side, and then we've got 4 of these triangles. Okay, and each triangle equals 3. So our equation is a divided by 3 equals 4. So put this on pause and try to determine what A equals. Okay, I'm anticipating that we're doing a pretty good job so far. So now what we can do is we can extend this and try out problems without the diagrams. So let me demonstrate a couple for you here, and then you're going to try out a couple at home. Okay, the first one we have is p minus 5 equals 2. Well, we know that 7 minus 5 equals 2. So that must mean that p equals 7. I'm going to try out this one here. 108 divided by I equals 9. Well, if we think back to our times tables, 108 divided by 12 equals 9. So therefore, I equals 12. So put this video on pause, please, so that you can do these two remaining problems. We can test different numbers to see if they give us a correct solution. Here's an example. Which of the numbers 5, 6, and 7 is the correct solution for the equation 4x plus 3 equals 27? Well, here's what we have to do. We have to try out each number. So let's say x equals 5. So we're going to have 4 times 5 plus, okay, that equals 23. So we know that that's not right. Let's try out x equals 6. So we've got 4 times 6 plus 3. And that equals 24 plus 3, which equals 27. So we know right now that we have our correct answer right here. If we use 7 for x, we would get a number greater than 27, and that's not what we want. So 6 is the correct number. Okay, good stuff. All right. Been a while since I've done this, but let's end off with a dumb joke of the day. When danger arises, the doctor races to his TARDIS and flies to the rescue. But there's one thing the doctor cannot rescue us from. That's your math homework, which you're going to be working on in tomorrow's class. And here it is, giving you a sneak preview. A lot of questions I know, but they're really quick. And given how we're progressing through this unit, I think we should be doing fine with this work in tomorrow's class. But until then, this concludes today's video.